A very good afternoon, students. Today's lecture will be on fundamental parameters of traffic flow. Till date, we have discussed about the different types of pavement and the design. Today, however, we will be talking about the traffic flow parameters. Now, in case of the traffic flow parameters, we need to understand why do we need to study this particular thing. Obviously, in case of the pavement, we have seen that there is a need to understand about the traffic. The total traffic or the design traffic can be calculated. But other than that one, there are so many parameters which actually affect the entire traffic, and as a result, they will affect the pavement design as well as the geometric design. So let us go through this particular thing. Obviously, first of all, we are talking about the traffic engineering, which is the analysis of behavior of traffic to design the facilities. Facilities means the geometric design as well as the pavement design. Now, traffic stream includes combination of driver and vehicle behavior. The driver or human behavior being non-uniform. Non-uniform means from one person to another person, this behavior will vary. As a result, the overall characteristics of the traffic will be different. So they are not homogeneous, they are of heterogeneous nature. Thus, a flow of traffic through a street of defined characteristics will vary both by location and time corresponding to the changes in human behavior. That is why we need to study the parameters have been classified into two categories. One is macroscopic parameters like the speed, flow and density, and the microscopic parameters which are derived from these macroscopic parameters like the headway and spacing. The macroscopic parameters like the total speed of the flow or the flow of the traffic. So macroscopic parameter will include the entire thing in a bigger scale. That means the overall traffic stream will be considered. But in case of the microscopic parameters, the individual vehicle will be coming into the picture. First of all, speed. It is obviously from your basic class 9 concept. You can easily understand it is the measurement of the ratio of distance divided by time. So it is denoted as small v, the distance is small d, and the time is small t. So the unit will be meter per second or kilometer per hour. Speed of the different vehicles will vary with respect to the time and space, which means if you move continuously in a traffic stream, the entire speed of the traffic stream or your vehicle itself will not be the same. It will vary. So as a result, we have categorized these into different parts like the spot speed, running speed, journey speed, timing speed, and space mean speed. Now let us try to understand each and every type of speed. First of all, spot speed. It is the instantaneous speed of a vehicle at a specified section. That means when one vehicle is moving at a particular point of the road section, the speed will be calculated with the help of different measuring devices. That is called as the spot speed. Spot speed is actually helps us to understand the behavior of the traffic and to design the different things like the traffic signs, signals, the speed zone determination. You will be able to understand all these things in your next few lectures. Then the accident analysis, road maintenance and congestion can be understood by the spot speed data. Now, I have talked about the measuring devices. The measuring devices are like the inoscope, or in very simple words, it is the speedometer, radar speedometer, or some photographic method. Okay, some measuring devices are there, and we can easily measure the what speed of a vehicle. Next is the running speed. It is the average speed maintained over a particular course while the vehicle is moving, and it is the length divided by the time. Obviously, when the vehicle is moving, the only then the time will be considered. That means when the vehicle will be stopped due to the congestion of the traffic or due to any signal, that time will not be calculated. Only the time at which the vehicle is actually moving will be considered. If there is no delay, if there is no delay means if the vehicle is not stopped, then the running speed is ideally equal to the journey speed. Next one is obviously the journey speed. It is the effective speed of the vehicle on a journey between 2 points, and the time will be taken considering all the times including the stoppage time of the vehicle. Now we will be moving to the next section where two different speeds are there. One is time mean speed and other one is space mean speed. From the first one, time mean speed, you can easily understand with the name is that it is a mean speed, that is the average of the time. That means it is defined as the average speed of all the vehicles passing a point on a highway over some specific time period. So that means you are given a time of say 2 minutes. On those 2 minutes, the number of vehicles will be passing will be having some speed, and after calculating their speed, you will get the mean speed. That is called as the time mean speed. So it is directly related to a specific time period. The second thing is the space mean speed. It is defined as the average speed of all vehicles occupying a given section over some specified time period. But here the thing is that the same thing has been repeated like the time period. But when you are going to calculate that space mean speed, it is the average speed of vehicles occupying a specific section on a road. Obviously, when the speed is getting calculated, the time will be a factor, but for the space mean speed, it is directly related to the space or the section of the road. Obviously, they are the relative measures and they are not same across the entire journey. So the vehicle timing speed or stationary speed will definitely vary. So after getting the speed, we will be talking about the second traffic flow parameter, that is known as the flow. It is obviously can be called as the volume. So it is the number of vehicles per unit time. So if the number of vehicles is small n, per unit time is c, so flow is denoted with q. So q equals to n divided by 2, which is also can be called as the volume. Since there is variation in the volume of traffic, several types of measurements of the volume are commonly adopted, and they will be discussed in the next part. The first one is average annual daily traffic, AADT. It is the average of all the number of vehicles passing in a given location over a full 365 days of a year. So that is why average annual daily traffic. So you will get the total traffic with annual traffic, and then you will need to divide it with 365. Second is average annual weekday traffic. So number of weekdays has been taken as 5 and per week, and it is consists of 52 weeks. In a year, there are 52 weeks. So 52 into 5 is equal to 260. So the average traffic will be again calculated with the help of the value of 260. 52 number of weeks are there in a year and 5 days per week. So that means total of 260 days, and the total traffic will be done average with the help of dividing it with 260. So that means average annual weekday traffic, AAWT. We actually use this AADT much more than the AAWT. Third one is average daily traffic. Obviously, it is considered for 6 months or a season or a month or a week. So it is average of the specified time period on which we will be doing the surveys. I will be talking about the surveys later on. And obviously average weekday traffic is again the same like the average annual daily traffic. So remember, in our pavement design, we were talking about the AADT, average annual daily traffic, when we will be considering the total amount of vehicles or the total volume of traffic, then we will be taking AADT in most of the cases as per the IRC recommendation. So next up is the density. It is defined as the number of vehicles, which is an X, occupying the given length, kept X, of a highway, and it is generally expressed in vehicles per kilometer. So number of vehicles divided by kilometers, and it is generally denoted with K. So in this particular road section, you can see that there are 4 vehicles for this particular road length. So for this road length, K will be 4 divided by this. From the fundamental traffic flow characteristics like flow, density, and speed, there are few other parameters which can be derived. They are known as the microscopic parameters, like the time headway, the distance headway or space headway, and the travel time. This is our last slide for the day. Obviously, time headway. Obviously, it is related with the time. So that means it is a measurement of time between the passage of one rear bumper and the next part of a given point. So that means from one bumper to the another bumper, what is the time required for the two vehicles to move? Suppose there is a line in a road section. One of the vehicles will be crossing that particular line, and when its rear bumper will cross that line, we will start the calculation. Next, after some time lapse, the second vehicle will be coming from behind, and also it will cross that particular line with its rear bumper. So the time taken in that case will be considered as the time headway. Second one is space headway. It is directly related to the space required. Okay, so it involves the measurement of the rear bumper of the front vehicle to the rear bumper of the vehicle which is behind. So if we calculate these two things, the distance between them obviously, then you can understand the space headway of the particular road section at a given point of time. Third one is travel time. It is defined as the time taken to complete a journey. Obviously, this time will include the in-vehicle travel time. That means the time which we are spending inside the vehicle is in-vehicle travel time, and off-vehicle travel time. That is the time we are spending outside the vehicle. That means whenever we are starting one journey, we will be walking. So that walking time will be calculated in off-vehicle travel time. After reaching a bus stop or an auto stop, we will need to wait for bus or auto to arrive. So in that particular case, that will be the waiting time. So all these things will be taken care in case of the off-vehicle travel time. So together off-vehicle travel time and in-vehicle travel time will create the total travel time. So this is our today's class. Obviously, we'll be talking about the interrelationship between space, space headway, and time headway, as well as the interrelationship between speed, flow, and density in our next few classes. This will be the last chapter, obviously, in your syllabus, but it will need some time to complete. Obviously, we will be sending you the notes to this particular this video lecture, and other than that, we will be sending you some PDFs also. You have got the book of Khanna Jasto. Obviously, the e-book is also available as sent by Shogun sir. I hope you will be able to understand the basics of it. If you face any kind of problem, you can easily call me, or you can always give me some queries to your Google Classroom that I created long back, or through the email or WhatsApp. So this is it for today. Obviously, I have mentioned one more thing, that I'll be giving a brief of the pavement design, which I'll be sending in a few days. But that is the total briefing of the pavement design, the rigid pavement design. But that is a different topic. Obviously, you need to concentrate now for this particular thing, and I hope you'll be able to get through the things easily. Thank you.